So in the previous class, so what all things we have discussed? We have started with the preparations, right? We have seen the general methods of preparations for both aldehydes as well as ketones. Okay. So what is the aldehyde group? What is the aldehyde group? Right. So this is a aldehyde group. Right. So this is a aldehyde group. So it contains what? A carbonyl carbon. Right. So it is containing a carbonyl carbon. Ketones also consist of a carbonyl carbon, but both besides the carbonyl carbon, both are alkyl or the aryl. Here only one of the substituent is what? Alkyl or aryl, right? So this is the difference between aldehyde and ketone. Then let's start with the general methods of preparation. So which are methods of preparation we have discussed? So we have discussed first one was by controlled oxidation of alcohols, right? So we have seen which is the oxidizing agent used. It was K2Cr2O7 and H2SO4, that is potassium dichromate, okay, and sulfuric acid. Right. So if you treat this with a primary alcohol, so if you take a primary alcohol and if you treat it with a K2Cr2O7 in the presence of dilute H2SO4, okay, the condition is you have to take a dilute sulfuric acid. Okay, then what you will get? You will get a aldehyde. You will get what? Aldehyde. So what happens here? There will be loss of hydrogen. Okay, oxidation means there will be loss of hydrogen. Okay. Then accordingly, if I take a secondary alcohol, okay, if I take a secondary alcohol, okay, and again, if I do a oxidation, now I'm taking K2Cr2O7 in the presence of concentrated H2SO4, okay, in the presence of concentrated H2SO4, what I'm going to get? I'm going to get a ketone, okay, I'm going to get a ketone. Now, again, what is lost here? Hydrogens are lost. Got it? So these things we have seen in the previous class. So this was a first. So by this, that is by doing a controlled oxidation on alcohols, we will yield both. So we can get both aldehydes as well as ketones also. Okay, so these are general methods. So by these methods, we can prepare both aldehydes as well as ketone. Then the second method of preparation, which we had seen, dehydrogenation reaction. Okay, so what we did in dehydrogenation means removal of alcohol. Sorry, removal of hydrogen. Okay, removal of hydrogen, H2 molecule. Okay, removal of H2 molecule. So this is a dehydrogenation reaction. So what we took, again, we took a primary alcohol. Okay, we took a copper metal and we heated at a temperature of 573 Kelvin. We get what? We get a aldehyde. Okay, we get a corresponding aldehyde with primary alcohol. Again, if you take a secondary alcohol, again we treat it with a metal, that is a copper metal, and heat at 573 Kelvin. We get what? We get a ketone. Okay, corresponding ketone we get. So dehydrogenation reaction is also again a general methods of preparation. By this method, we can prepare both aldehyde as well as ketone. Okay, so if I take a primary alcohol, you will get aldehyde. If I get a secondary alcohol, we get a ketone. Okay. So these two we had seen. Then we had seen ozonolysis, very important. Okay, I told you this is a important. So what we are doing? We are doing ozonolysis of alkenes. Alkenes are what? Alkenes are the unsaturated compounds, right? With a double bond. Unsaturated compounds with what? With double bond. Right. So they are alkenes. So what we are doing, ozonolysis means what? We are adding addition of ozone molecule. Okay. Ozone is O3. So addition of ozone molecule across double bond. Okay. So it is called as ozonolysis. Okay. Ozonolysis. We are adding ozone molecule across double bond, and lysis means then we are breaking that bond. Okay, and then we get the respective product. Now what we have done here, just see, we have taken, so I'll show you again. So RCH double bond CH2 in the presence of O3. Okay, what we are going to do? The rest all things will remain the same. Okay, rest all things will remain the same. So this here the ozone molecule is added. Right. So ozone molecule is added. Now again, what will happen here? Just see. So like this, the breaking of bond takes place in the presence of zinc dust and water. And what I'm going to get R C H O plus H CHO. So this is a formaldehyde is a common product. Okay, formaldehyde is a common product obtained in all the reaction when it is undergoing ozonolysis. Again, so this was a uh, this what unbranched alkene. So whenever you have a unbranched alkene, unbranched means there is no branching present here. Now this is a branched alkene. So whenever you have a unbranched alkene, okay, what you will get? You will get a aldehyde. So remember this important. Okay. So whenever you have a unbranched alkene, you will get a aldehyde. Whenever you have a branched alkene, okay, whenever you have a branched alkene, what you are going to get? You are going to get a ketone. Okay, you are going to get what? You are going to get a ketone. Okay, fine. Okay. So we'll see for ketone if you want. Okay. So how it is R double this R dash, okay, and CH2. So across this double bond, so rest all things will remain same, okay. Rest all you have to write same. So only across the double bond, where the double bond is present, what will happen? The breaking will take place, okay. So this is a ozonide. So this compound is called as what? Ozonide. So this is a ozonide, okay. Now ozonide, so it will undergo breaking and what we will get? R C double bond O R dash plus HCHO. So you get a ketone and again I'm going to get a formaldehyde. Is it clear up to here? Yes. Is it clear? Any doubts up to here? So this I've explained in the previous class. Still uh, a, a quick revision. Okay. So is it clear? Okay, fine. So let us go for the fourth one from alkynes. Alkynes means from triple bond. So compound with a triple bond, right? Alkenes, alkynes. Alkynes are also unsaturated compounds with triple bond. So what we are doing here? We are doing hydration. We are doing what? We are doing hydration. Hydration means what? Hydration means we are adding water molecule, addition of water molecule. Okay, addition of water molecule. So by this method, what we can do, we can prepare aldehydes and both ketones. Okay, we can prepare both aldehydes and ketones by doing hydration on the alkynes. Okay, and in the presence of HgSO4 and H2SO4. So in this presence of this particular HgSO4, or that is your mercury sulfate, or in the presence of the sulfuric acid, you can do the hydration. Okay. Okay. So what we are doing here, we have taken a CH triple bond CH. Okay, so this is a acetylene. So when we add a water molecule in the presence of H2SO4 and 1% HgSO4, okay, it will undergo a ketoenol system. Okay, it will undergo a ketoenol system. So what do you mean by ketoenol system? So here in all means in is in. Okay, that is your alkene. So alkene is your ene, right? In and so your alkene and alcohol, right? That is a alcohol. So it is a in and okay, ene and this is all. So alkene and alcohol together they make up enol. Okay, and so enol and keto system. So they undergo tautomerism. Okay, they undergo tautomerism means what? They will have same molecular formula, only there will be what? They can easily form enol and ketone. Okay, they can easily rearrange themselves to get you keto-enol system. So like this, you get a your aldehyde. Okay, so if you have a acetylene, you will yield only aldehydes. Other than acetylene, if you take any triple bond compound, so here you can see, right? This is a propylene, right? So this is a propylene. So when you have a propylene, you will get what? Ketone. So other than acetylene, if you take any other alkynes, you will get ketones as the product. So these things you have to remember. So it will undergo a ketoenol tautomerism. Okay, it will undergo ketoenol tautomerism. Okay, so now we are going to discuss about the preparation of aldehydes. Okay, preparation of aldehydes. So let us see the preparation of aldehydes. So specifically, we are discussing only on the preparation. So now we have seen four general methods of preparation. So in that general methods of preparation, we have discussed what we can prepare both aldehydes as well as ketones. Now the from this preparations, what we are seeing, only we can specifically what we can uh, prepare is only aldehydes. So the first one, very important, mark this important for 2 marks. Mark this important for 2 marks. Preparation of aldehydes from acyl chlorides. Okay, preparation of aldehydes from acyl chlorides, or they are also called as acid chlorides. Okay, so what we are doing, we are taking a acid chloride. So this is our acid chloride. Okay, this is a acid chloride, or you can say as acyl chloride. Okay, and we are doing hydrogenation. Hydrogenation means what? Addition of hydrogen molecule. Okay, over a catalyst. Which is the catalyst taken? We can take palladium. Okay, that is PD on barium sulfate. So you can take palladium on barium sulfate, and it forms what? And it forms aldehyde. Okay, and it forms aldehydes, and this famous name reaction is called as Rosenmund reduction. Okay, Rosenmund reduction. So what we are doing? What we are doing here? Reduction means what? Reduction means what, students? Addition of hydrogen. Right. So what we are doing here? We are doing reduction. So from what we are doing, what is our starting product? Acid chloride. Okay, we are doing acid chloride. Okay, acid is what? This is our acid, carboxylic acid. So what we have done here, OH is replaced by Cl. So it becomes acid chloride. Okay, it becomes acid chloride. So what we have taken an acid chloride. Okay, and we have treated, we are doing hydrogenation. That is, we are adding hydrogen molecule, which is a catalyst, palladium and barium sulfate. Okay, palladium and barium sulfate. What you will get? You will get aldehyde. So what is happening here? Your Cl is replaced by what? Hydrogen. Okay, and this famous reaction, it is called as Rosenmund reduction. So what can be a question? The question can be, explain Rosenmund reduction with example. Okay, or they can ask you to prepare aldehyde from starting product as acid chloride. So like this, so you have to prepare from both the ways. Got it? Is it clear? So general reaction. So this is example. Okay, this is example. Generally, how the reaction is given, you please note it down. So this is a general reaction, what I'm writing. So 2H in the presence of palladium, okay, and barium BaSO4 will give you plus HCl. So this is general reaction. Okay, this is a general reaction. So this is what? This is a acid chloride. Okay, this is acid chloride. We are doing hydrogenation in the presence of palladium and barium sulfate. You'll get a aldehyde. You'll get what? Aldehyde. Is it clear? Rosenmund reduction. Reduction is what? Addition of hydrogen. Is it clear? Yes, is it clear? Okay. Can you tell me the product obtained for this now? So this is first example. This is second example. Okay. So this is general reaction. Please note it down. General reaction. So they can ask you general reaction, also explain Rosenmund reaction with the example. If example, you can explain this with example like this. If they ask you give a general reaction, then you have to give this general reaction. Okay. Tell me the answer for this second one. Yes, what will be the answer, students? Acid chloride in the presence of, okay, we are doing hydrogenation. We are going to add hydrogen. Okay. What will be the product? What you can see here, your Cl is replaced by H. So here also it will be same. So what it will be? CH3, C double bond O, H plus HCl. Right. Is it? Yes. So what is the name? So this is a benzyl chloride and we are going to get benzaldehyde. Benzyl chloride, benzaldehyde. This is what? Acetyl chloride. This is acetyl chloride and we are going to get acetaldehyde. Acetaldehyde. Okay. So general reaction. So what we are doing, we are taking a acid chloride. We are going to do hydrogenation. Hydrogenation means we are going to add a hydrogen molecule in the presence of catalyst like palladium. In the presence of barium sulfate, we'll get a aldehyde and HCl. Okay, we'll get aldehyde and HCl. So this is the products which is obtained. So this aldehyde, it cannot reduced further. Okay. So we will get only aldehydes here. So from this reaction, formaldehyde cannot be prepared. Formaldehyde is the first aldehyde. Okay, we cannot prepare formaldehyde from the Rosenmund reduction. Okay. Next is by reduction of nitriles and esters. Okay, by doing reduction on nitriles and esters. What do you mean by nitriles? Nitriles are nothing but cyanides. Okay, nitriles, cyanides. So nitriles are what? C triple bond N, right? So these are the nitriles. So we are doing reduction. We are going to add a hydrogen molecules. Okay, have a mole of hydrogen molecule across this triple bond. So what? So important again. Mark this important for 2 marks. So this was also important for 2 marks. Okay, so what we are going to do here? We are going to take nitriles, okay, or cyanide, and we are going to convert it into imines. Okay, we are going to convert it into imines by reacting it with stannous chloride. Reacting it with stannous chloride in the presence of hydrochloric acid. Okay, and this will undergo hydrolysis to give you aldehyde. To give you what? Aldehyde. Got it? So what we are doing? We are taking cyanides. We are going to do what we are going to convert cyanide into imine by reacting it with stannous chloride. Okay, we are going to take cyanides. We are going to treat it with stannous chloride. Okay, in the presence of hydrochloric acid to give you corresponding imines. This imine will further go hydrolysis. It will undergo hydrolysis to give you what? It will give you hydrolysis to give you aldehyde. Okay, so this is a general reaction. This is a general reaction. So please note down the general reaction first. Note down the general reaction first. So ammonia gas is liberated. Okay, so I'll write the names here. So this is the aldehyde. So cyanide is treated with stannous chloride. Okay, so you can read out this. So they can ask you, and this name reaction is called as stiffened reaction. This name reaction is called as what? Stiffened reaction. So they can ask you explain stiffened reaction with a general mechanism or general reaction, or give a example. So what you have to explain, nitriles are reduced to corresponding imines by treating it with stannous chloride in the presence of hydrochloric acid, which will undergo hydrolysis to give you aldehydes. Okay. So this is called as stiffened reaction. So this is a general reaction. This is a general reaction. Okay. So now let us see the example. So mark this as important. Okay. Stiffened reaction, Rosenman name reaction. So all these name reactions are very important. Okay. Let us see one example. You have to tell me. So let me take it as CH3Cl. Okay. Plus SnCl2. So this is the general reaction. Now I have taken the example. General means what? Your R group is not substituted. Now this R, I have taken CH3. I have taken CH3. Okay. And this is a nitrile group. So in the presence of SnCl2, that is stannous chloride, in the presence of HCl, what I'm going to get? Tell me the products now. So this is a ethane nitrile. Okay. This is a ethane nitrile. Okay. Can you tell me what is the imine? Which imine is produced? Only replace your R here. So it will be CH3, CH, double bond, NH. Okay, so this is our imine. Now this imine will undergo hydrolysis, which is the aldehyde. Acetaldehyde. Okay, we are going to get acetaldehyde. Got it? Yes. So what we are doing, we are taking nitriles, or they are called as cyanides. Okay, nitriles or cyanides, that is C triple bond N. So these are called as nitriles or cyanides. So what we are again reducing. Okay, we are reducing means what? You can see here, C is there. We are adding again hydrogen across the triple bond. Across the triple bond, we are adding a molecule of hydrogen, and then what we get, we on hydrolysis, we are going to get aldehyde. Okay, so nitriles are reduced to corresponding imines with the stannous chloride in the presence of hydrochloric acid, which on hydrolysis will give you corresponding aldehydes. And this particular name reaction is called as stiffened reaction. Okay, so Rosenwald reduction and stiffened reaction, is it clear? Okay, fine. So let us go for the next one. So how we treated, so in the previous reaction, we have taken nitriles and we have treated it with SnCl2 and HCl. Okay, what we got? We got imines. And this imine was further hydrolysis. We had done hydrolysis to give you what? Hydrolysis to give you corresponding aldehydes, right? Now here in this particular, again, what we are going to take? We are going to take nitriles, okay, nitriles or cyanides, and we are going to treat it with Dibal H. Okay, what is this Dibal H? Diisobutyl aluminium hydride. Okay, diisobutyl aluminium hydride. Okay, so when you do this, what it is going to do, we can, from nitriles, we can convert it into imines, and this imines further will hydrolysis will give you aldehydes. Okay, so from this also we can do correspondingly reduction. So either you can take stannous chloride in the presence of hydrochloric acid, or I can take Dibal H. Okay, that is diisobutyl aluminium hydride. Okay, so we can take any of this and we can do what? We can do the reduction. So what we can do? We can convert the nitriles into corresponding aldehydes. But that is stiffened reaction. Okay, and here, okay, so this is a reduction only, but we are going to do it with Dipal H. So another reducing agent, okay, which will undergo reduction, So here is an example. So this is the general reaction again. So what they have taken. So this is your, okay, this is your what? Your R group. So R group is your butene. Okay. So what we have done here, so that we are going to treat it with Dibal H and followed by hydrolysis. What I'm going to get? So your cyanide group will be converted into aldehydic group. Okay. What is the change? Rest all things will remain the same. Only your cyano group. So what will happen? There will be a triple bond. So across this triple bond, one of the bond is broken first, and what I'm going to get? I'm going to get the C double bond N. Okay, like this I'm going to get. That is a imine system. Now this imine further undergoes hydrolysis to give you what? I'm going to get the aldehyde. I'm going to get what? Aldehyde, like this. Okay, is it clear? So similarly with esters also. What do you mean by esters? Esters are this, right? So these are esters. So we can do a reduction on esters also. So your R C double bond O R dash. So our R is CH3, R dash is C2H5. So again with Dipal H and water, we are going to get aldehyde and alcohol. Right, we are going to get aldehyde and alcohol. So esters are also reduced to aldehyde with Dibal H at low temperature. Okay, so the temperature condition is low. So here also the temperature condition is low temperature. Okay, at a very low temperature, we are going to convert the nitriles into aldehydes with Dibal H. Okay. So if there is double bond also in the alkene group, so it won't change. Okay. So by doing the reduction with the Dibal H, the double bond will not be disturbed. Only the change will be at this cyano group. Only at the cyano group, the change will be occurring. So this is the reduction of nitriles and esters. Okay. So two main name reaction you have to practice today. Rosenmund name reaction and Rosenmund reduction and stiffened reaction. Okay, please note this down. Very important. Rosenmund reduction and stiffened reaction. Okay, in stiffened reaction, what we are doing? We are taking nitriles. We are treating it with stannous chloride in the presence of hydrochloric acid. What I'm going to get? I'm going to get imines. This imines, okay, I'm going to do hydrolysis to give you aldehydes. So you have to follow these steps. Okay, nitriles. So if I write nitriles is R C triple bond N in the presence of stannous chloride and HCl will give you imine system. Okay, I'm going to get a imine system, that is RHCH 1, 2, 3. Just a second. RCH double bond NX 1, 2, 3, 4. Yes. Okay, so this is a imine system. This imine will undergo hydrolysis to give you RC double bond OH. Okay, so this is the and plus NH3 is given up. Fine. So this is the stiffened reaction. Okay. So next is from hydrocarbons. So next is from hydrocarbons. What are hydrocarbons? Compounds containing hydrogen and carbon only. Okay. So we are going to do from hydrocarbons. So what we are going to do? So aromatic aldehydes. So aromatic aldehydes like benzaldehyde. Okay, like benzaldehyde and its derivatives. Okay, benzaldehyde and its derivatives are prepared from aromatic hydrocarbons. So from aromatic hydrocarbons, we can obtain aromatic aldehydes. Okay, first is by oxidation of methyl benzene. So if you do oxidation of methyl benzene, that is methyl benzene is toluene. Okay, methyl benzene is toluene. Methyl benzene is toluene. Okay. So what we can do, we can use strong oxidizing agents. Okay. Like your chromyl chloride. Okay. You can use chromyl chloride in the presence of, okay, in the presence of CS2. You can, so this is a toluene. Okay. This is a toluene. Toluene, when you react, that is methyl benzene. Okay, you have a substituted benzene group. So this is an aromatic hydrocarbon. So you have a methyl and a benzene. So it is a methyl benzene, or it is called as what? It is called as, or it is called as what? It is called as toluene. Okay, the common name is toluene. So toluene, when you react it with chromyl chloride, okay, chromyl chloride in the presence of carbon disulfide. Okay, in the presence of carbon disulfide, carbon disulfide, what I'm going to get? I'm going to get a chromium complex. I'm going to get a chromium complex. This chromium complex will undergo hydrolysis. I'll get hydrolysis to give you benzaldehyde. Okay, what I'm going to get? I'm going to get a benzaldehyde. Okay, so O CrO HCl2 twice. Okay, so this is a chromium complex. So this particular name reaction is called as Itard reaction. Okay, this is another name reaction, important. Mark this as important again. 2 marks. Explain Itard reaction. Explain Itard reaction, and Itard reaction is done only on methyl benzene. Okay, on methyl benzene. Fine. So what we are going to do? We are going to take toluene. We are going to treat it with chromyl chloride in the presence of carbon disulfide to give you a chromium complex. This chromium complex will undergo hydrolysis to give you a benzyl aldehyde. Okay. Got it? Important. So which all name reactions you have to practice? Rosenmund reduction, Stephen, and Itard. So all this name reaction you have to practice today. Okay, you have to practice today. So how you will practice? So first, read it. Okay, twice or thrice you read it. Twice to thrice you read it, and then you have to write and practice. Okay, then you have to write the reactions and practice. See 2 times. Okay, first you read the reactions, understand the reaction. Okay, and then what you can do, you can just write it by seeing the reaction. Okay, understand what is happening, and then you can write the reaction without seeing. You can write the reaction without saying. So this is another name reaction, that is a Ithard reaction. Ithard reaction. Okay. Next. Next is, again we are going to do oxidation. We are going to do oxidation on what? We are going to do oxidation on toluene. Okay. What we are doing? We are taking toluene. We are going to treat it with CrO3. Okay. That is your chromic oxide. Okay. With your chromic oxide. Okay. In the presence of acetic anhydride. In the presence of what? Acetic anhydride. So this is acetic anhydride. So the temperature condition is 273 to 283 Kelvin. So at a very low temperature, that is 273 to 283 Kelvin, okay, it gives you a benzidylene diacetate. What it gives you? It gives you a benzidylene diacetate. Okay, so I'll show you how this reaction will proceed. So this is this is my toluene. Okay, this is my toluene in the presence of CrO3 plus CH3, C double bond O. Okay, CH3, C double bond O. So this is my acetic anhydride. Okay, this is my acetic anhydride. So what will happen? What will happen here? So these are the two molecules. Okay. So just see what will happen. So here your CH. Okay, CH. Then oxygen will get attached. Oxygen, C double bond O, CH3. Then again one molecule of your O2. So this oxygen is shared. Okay, so again O, C double bond O, CH3. So this is benzidylene diacetate because these are two acetate groups. CH3, C double bond O is what? Acetate. So two molecules of acetate are there. So it is diacetate. So benzidylene diacetate. Now this benzidylene diacetate will undergo hydrolysis. It will undergo hydrolysis, and what will happen? This will be converted into aldehyde. This will be converted into aldehyde. So this is another uh, what uh, what we can prepare our aromatic hydrocarbon, that is your aldehyde. Okay, aromatic aldehyde from aromatic hydrocarbon. So from a aromatic hydrocarbon, okay, from a aromatic hydrocarbon, we are preparing aromatic aldehyde. Is it clear? Is it clear? So what we are doing, we are taking toluene, we are taking a oxidizing agent. Okay. Now what will happen? So this is a your acetic anhydride. So your acetyl group are shared. Okay. So at this carbon, okay. So OCH3, C2CH3, OC2CH3, COCH3. So these two diacetate groups are added at the active carbon site, and you get a benzidylene diacetate. And this benzidylene diacetate, if you heat it followed by hydrolysis to give you what? You will get a aldehyde. Okay, aromatic aldehyde. Is it clear? Yes. So this is the another reaction where we are doing converting our aromatic hydrocarbons to aromatic aldehydes. So next is by side chain chlorination. Okay. So this is a commercial method. Commercial method means industrial method. Okay. Commercial method means what? Industrial method. By this we can prepare our benzaldehyde. Okay. Again, we are taking toluene in the presence of chlorine. Okay. In the presence of light. Okay. That is a chlorine. in the presence of light. H nu is nothing but light, sunlight. Okay. So chlorine in the presence of sunlight, you will get what? Benzyl chloride. So one of the hydrogen. So what will happen here? Just see here. So that is CH3. Right. So one of the hydrogen is replaced by Cl2 in the presence of H nu will give you what? So one of the hydrogen is replaced by your CHCl2. So two, because there are two chlorine molecules. So two hydrogen molecules are replaced by two Cl. Now this further so this is a benzyl chloride. This is a benzyl chloride. So this benzyl chloride will undergo hydrolysis. Okay, we are adding a hydrolysis in the presence of 373 Kelvin. Okay, what we will get? We will get a benzaldehyde. Okay, again, we are going to get benzaldehyde. So what we are doing? We are doing a side chain chlorination. We are introducing chlorine atoms on the side chain. So which is our side chain? Our methyl groups. So if you do a methyl group, so this is also controlled chlorination because we are taking 2 moles of Cl. Okay, if you take more Cl atoms, all these hydrogens will be replaced by Cl. So we are taking only 2 molecules of Cl. So 2 hydrogen atoms are only replaced by your Cl atoms. Okay. And then correspondingly, when we do hydrolysis, we will get benzaldehyde. So this is another method, okay, from which we can get our benzaldehyde. So in from hydrocarbons, we have seen 3 reactions. One was the ethyl, that is ethyl reaction, where we are treating our toluene with what? Bromyl chloride. Okay, bromyl chloride, and we'll get a benzaldehyde. Then second was with chromic acid. Toluene, when we react with chromic acid in the presence of acetic anhydride, you will get a benzidylene diacetate. On further hydrolysis, will give you benzaldehyde. And this was the third reaction where we are taking toluene in the presence of sunlight, okay, and chlorine molecules. We are going to get benzyl chloride. Two of the hydrogen atoms are replaced by two chlorine atoms. You will, on further hydrolysis, will give you benzyl this. Okay, that is benzaldehyde. Got it? So these are the reactions wherein we are only preparing our aldehydes. Next is Gattermann-Koch reaction. Important reaction, very important. Mark this important again. All the name reactions are important. Gattermann-Koch reaction. Now, what is this Gattermann-Koch reaction? So benzene. So this is our benzene. Okay. We are going to treat it with carbon monoxide in the presence of hydrochloric acid. Carbon monoxide in the presence of hydrochloric acid. Okay. In the presence of anhydrous AlCl3 or cuprous chloride. Okay, anhydrous AlCl3 or cuprous chloride, it will give you a benzaldehyde. It will give you what? A benzaldehyde. So what we are doing? Okay, we are taking benzene or we can take any of its derivative. We are going to treat it with carbon monoxide in the presence of hydrochloric acid, anhydrous AlCl3 or cuprous chloride. Okay, we are going to get benzaldehyde or substituted benzaldehyde. So all this is whenever, if it is asked question, explain Gattermann-Koch reaction, explain Rosenmund reaction. So whenever such questions are asked, you have to give explanation also, okay, and give the reactions also with all the this how you have to take benzene, write the name benzene, carbon monoxide in the presence of HCl, anhydrous AlCl3 and cuprous chloride will give you benzaldehyde. So like this, the thing should be mentioned. Okay. So is it clear? So this is another name reaction called as Gattermann-Koch reaction. Okay, Gattermann-Koch reaction. So carbon monoxide and HCl. Okay, we are going to introduce a aldehydic group on the benzene. So here, uh, so which are name reaction we have seen? We have seen Rosenmund reaction. Okay, Rosenmund reduction. Then we have seen Stephen reaction. Okay, then we have seen Itard reaction. Okay, and we have seen Gatterman Koch reaction. Okay, so these are the four name reactions we have seen. Okay, very important name reactions which are used for the preparation of aldehydes. Okay, so by this we are going to prepare what? Aldehydes. Is it clear? Any doubts up to here? Any doubts up to here? So these are the main important reactions. So any of these questions can be asked. So 2 marks question. Okay, the question can be explain Rosenmund reaction with an example, or it can be explain with a general reaction the Rosenmund reaction like this. So what you have to do, you have to give explanation, okay, statement, then explain the reaction. That is, you have to explain the reaction in the state in the form of statement. Then what? Write the reaction and write their names. Now, how it is written, Grignard reagent, okay, acyl chloride, this is ketone. So like this, you have to explain. Okay. So you should not miss these things. You have to write in organic chemistry. Okay. You should write the names here. Okay. You should not keep it blank. Now this benzene, they have not written. So you have to write here benzene. Okay. This is benzaldehyde. So whatever the main important this is there that you have to write. So these things also should be mentioned. How Gatterman-Koch reaction takes place. Okay, benzene we are going to react it with carbon monoxide in the presence of and that is your HCl in the presence of anhydrous aluminum chloride, or you are going to take cuprous chloride, you are going to get benzaldehyde. So the same reaction what you are going to write, you have to explain in the own words. Okay, that benzene we are going to treat it with carbon monoxide and hydrochloric acid in the presence of anhydrous aluminum chloride or cuprous chloride. We are going to get benzaldehyde. So this is Gatterman-Koch reaction like that. Okay. So today's homework, you have to go through these four named reaction. Okay. So because again tomorrow we are going to discuss about ketones. So again in ketones also you'll be having name reactions. Then we have carboxylic acid, right? So after completing this ketones and all. So again name reactions will be more. So again at the last, if you go to study, it will be very difficult for you. Okay. So at the last, if you study all the name reactions together, it will be very difficult. So there and there itself, you have to practice the name reactions and it will go easy for you. And if you find any difficulty, you can ask me the other dates. Okay. Is it clear? So if you find any difficulty, so today you have to go through all these name reactions. Okay. So I hope you have noted it down. Okay. And I have uploaded the last topic, that is chemical kinetics notes also. You can go through the notes. Okay. If you find any difficulty, you can ask me. Fine. Okay. Anything else you want to ask? Anything else? Any doubts? Anything you want to ask? Okay, fine. So today will you do the this division of this four named reaction? Yes. So I want you all to like practice this name reaction, that is Rosenmund reduction, Stephen reaction, Ittard reaction, and Gatterman-Koch reaction. Okay, so these four named reaction you have to practice today and come back tomorrow. Okay, so tomorrow we are going to discuss the preparation of ketones. So we have seen general methods of preparation. In general methods, what we are doing, okay, they are general methods in which we can prepare both aldehydes as well as ketones. Then we are separately discussing how we can prepare only aldehydes. So there are some special reactions from which okay, we can prepare only aldehydes. So that we have seen today. Tomorrow we are going to discuss about ketones, how we can prepare only ketones. Okay. So let us discuss that in tomorrow's class. Fine. So no doubts. Yes. Anything you want to ask? Any difficulty? Anything you want to share? Yes. No doubts? Okay, fine then. So we shall end the session here. Okay, we'll meet in tomorrow's class. Yes, fine. Thank you. Have a good day.